Okay, good morning to everybody. Welcome to Young Minds. Okay, today we discuss about 24th day of January 25th. Okay, evening shift question paper discuss. Okay, from that question paper, first we discuss about the first year concept questions. Okay, the first question is the energy E and the momentum P of a moving body of mass m are related by some equation. Given that c represents the speed of light, identify the correct relation. There are 4 options are given. From that 4 options you should select the correct option. Okay, to see, you know very well, this is the best example of verification of given equation with the help of dimensional analysis. It is one of the beauty of dimensional analysis. You know, here E is equal to what? Energy. E is equal to what? Energy. Energy is equal to ml t power minus 2. That means force into displacement is nothing but energy, isn't it? That means ml square t power minus 2 is the dimension formula of energy. P is equal to what? Momentum. P is equal to what? Momentum is equal to what? Mass into velocity, which is equal to what? ml t power minus 1. ml t power minus 1. Okay, c is the speed of light. C is equal to what? Speed of light. Speed of light equal to L t power minus 1. Okay, right. First you should take the first option. What is the first option? E square. E square means what? E square is equal to p c square. Okay, and E square is equal to m square c power 4. Why? Because according to dimensional analysis, like quantities are allowed to added as well as subtracted. That means in LHS side, what kind of physical quantity is there, in the right handed side also same kind of physical quantity, then only this equation is correct. Okay, at E square means what? E square means what? M square L power 4 t power minus 4 when you squaring it is equal to P is equal to what? M L t power minus 1 into c square. C square means what? L square t power minus 2, isn't it, which is equal to what? M L cube t power minus 3. So, which is not correct. So, option 1 is wrong. Now, further not go to E square is equal to whether E square is equal to m square c power, it is not required. Okay. Next, take option 2. What is that? E square means what? Already there. That means E square is equal to p c square as well as E square is equal to m square c square. Therefore, E square means what? E already there. What is that? When you square it, m square L power 4 t power minus 4 is equal to p. Momentum, what is that? M L t power minus 1 into c square. That means what? L square t power minus 2. Then you got m L cube t power minus 3. It is also not correct, isn't it? Similarly, E square is equal to, when you take the third option, E square is equal to p square c square. That implies as well as and E square is equal to m square c square. That implies, now we can write dimension formula. E square is equal to what? M square L power 4 t power minus 4, which is equal to p square means p square c square. P square c square. P square is equal to momentum. P square is equal to what? M square L square t power minus 2 into c square. What is it? L square t power minus. That implies m square L power 4 t power minus 4. Whether it is correct? E square is equal to m square L power 4 t power minus 4. Yes, it is okay. Okay, but m square c square, it is correct or not, once we can verify. And m means what? Mass square. C square equal to what? L square t power minus 2. Why? Because L t power square means what? M square L square t power. But in LHS side, m square L power 4. So, it is also not correct. Okay. Already when you take the fourth option, E square is equal to p square c square and E square is equal to m square c power 4. Already E square is equal to p square c square, you can prove it here, m square L power 4 t power minus 4 is equal to this thing up to here. Okay. So, these two are okay. What about this m square c square? E square is equal to what? M square L power 4 t power minus 4 is equal to m square, means what? M is mass square. C power 4 means what? C is the speed of light. L power 4 t power minus 4, L power 4 t power minus 4. So, this is also correct. So, from the given 4 options, okay, the correct one is, okay, what is that? This is the correct one. Fourth option is the correct one. Okay. So, this is the beauty of the dimensional analysis. That means, whether the given equation is correct or not, verified by using this dimensional analysis. Okay, right. Okay, second question. A solid sphere is rolling without slipping on a horizontal plane. To see, suppose this is a horizontal plane. On this horizontal plane, okay, what happened? A solid sphere is rolling. That means it rolls like this. It rolls like this without slipping. Okay. So, you know very well its center of mass is follows, what is that? Translatory motion. Its center of mass is follows what? Translatory motion. Okay. So, what is its linear kinetic energy? Linear kinetic energy equal to what? Half m v square, isn't it? But here the solid sphere is rolling without slipping, that means it is rolls. Okay. Any rolling body having rotational kinetic energy. What is that? Rotational kinetic energy. Rotational kinetic energy. What is that? Half I omega square generally. But in case of solid sphere, in case of what? Solid sphere, you know this rotational kinetic energy is equal to here I is equal to moment of inertia, moment of inertia of, okay, rolling solid sphere, of solid sphere. Okay, actually which is equal to, what is that? Which is equal to 2 by 5 m into r square, 2 by 5 m r square. Okay. Therefore, what is asking? The ratio of the linear kinetic energy of the center of mass of the sphere and rotational kinetic energy. Therefore, linear, that means kinetic energy, okay, linear by kinetic energy rotational is equal to half m v square by half into, what is that? 2 by 5 m r square into omega square. Okay. But we know the relation, but we know that, what is that? V is equal to what? R into omega. This is the relation between linear velocity and angular velocity. Why? Because here the body is simultaneously roll, okay, along with linear motion. So, that V square is equal to what? R square omega square. Okay. So, it may be write like this. Therefore, half m v square by half m into r square omega square is replaced by v square, half m v square into what? 2 by 5. This half m square is equal to what? Cancel. Then answer equal to what? 5 by 2 is only remaining. So, answer of this question is equal to what? 5 by 2. Okay, right. Okay, the third question. The position vector of a moving body at any instant of time is given by okay, r bar is equal to this thing. The magnitude and direction of velocity at time t is equal to 2 second is, this is asking. Okay, what is the given position vector? Position vector of a particle, what is that? R bar is equal to 5 t square I cap minus 5 t j cap meter. Find its velocity and direction. So, velocity, this is the position vector of a moving body. So, its velocity at any time, velocity v bar is equal to what? Derivative, first derivative of displacement, dr bar by dt is equal to what? D by dt of 5 t square I cap minus 5 t j cap, which is equal to 5 into 2 into t, isn't it, into I cap minus 5 into j cap, which is equal to what? 5 to the 10 t I cap minus 5 j cap. So, this is the, but this velocity you should calculate at time t is equal to 0. At time t is equal to 2 second, what is the velocity vector? 10 into 2 into I cap minus 5 j cap, what is that? 20 I cap minus 5 j cap, 20 into I cap minus 5 j cap. Okay. So, magnitude, that means mod v bar is equal to 20 square plus minus 5 square, what is that? 400 plus 25, root over 425, what is that? Root over 425. Okay. When you multiply it, which is equal to what? 5 root 17 meter per second. So, magnitude is okay. What about the direction? Direction, you know, when you draw this body position, this particle is moving in an xy plane. Why? Because in position vector it is a component of I, means I cap is the unit vector along the x axis, j cap is the unit vector along the y axis. So, the body is moving in a plane. So, when you draw a plane, what is the I component? 20 plus 20, that means what? Particle magnitude along the positive x axis is equal to 20. Okay, the component of j equal to what? Minus 5, that means this is the, that means the particle position vector, that means its magnitude in the y axis is equal to what? Minus 5. So, the resultant is nothing but what I say, like this way, this equal to what? Resultant. So, you want to calculate direction, therefore, tan theta is equal to y component by x component, that means minus 5 by 20 equal to what? Minus 1 by 4. Here negative sign represent what? Its direction is along in fourth coordinate, when in what? Fourth coordinate, y, sorry, y by, that means with respect to this one, this is called theta. So, this is opposite by hypotenuse, sorry, this is 20 by 5. So, which is equal to what? 4. That implies theta equal to what? Tan inverse 4. This is the direction. Okay, that's it. Okay, the fourth question. A solid sphere and hollow sphere of same mass and same radius are rolled on an inclined plane. Okay. Let the time taken to reach the bottom by the solid sphere and hollow sphere be T1 and T2 respectively. Then, what is the relation between T1 and this is asking? What is that? A solid sphere and a hollow sphere. To see, this is the horizontal. Okay, a plane is make an angle there. This is called, this is the inclination angle. Okay, what happened? A solid sphere and a hollow sphere, okay, of same mass and same radius are rolled on an inclined plane. So, without slipping. Okay, so it is like a freely falling body. It is like a freely falling body. Freely falling body. You know that for freely falling body, time of descent to to reach the time taken to reach the ground from the maximum height. Time of descent T is equal to what? Root over 2h by g. Okay, but here a solid sphere and a hollow sphere of same mass and same radius are rolled on an inclined plane. So this is the g is nothing but what I say, acceleration, center of, okay, acceleration of center of mass. Okay, so from this you can take, okay, both are falling from same height, moreover both are same mass and same radius, but solid sphere and hollow sphere both are different densities, so that due to the difference in density their time period may be changed to reach the bottom from top. So that time period is directly, that means inversely proportional to root of center of mass, of acceleration of center of mass. Okay, so for solid sphere, you know, first you can take for a solid sphere, acceleration of center of mass. What is that? Acceleration of center of mass is nothing but 5 by 7 g sin theta. Okay. Similarly, for hollow sphere, acceleration of, what is that? Acceleration of center of mass is nothing but 3 by 5 g sin theta. Okay. So compared to this one, that means for a solid sphere having more acceleration of center of mass, therefore from a center of mass for solid sphere is greater than a center of mass for, what is it, hollow sphere. Okay, therefore time taken to reach the ground from the top of this inclined plane for hollow sphere take less time than the okay, solid sphere. So this is the relation, okay, between the time of, okay, time taken to reach the bottom by the solid sphere and the hollow sphere from, okay, from this inclined plane. So the answer will be T1 less than, what is that, T2. This is the answer for this question. Okay, right. The fifth question, a particle oscillates along the x-axis according to the law. What is that given? What is given? The position of a particle changes with respect to time, followed by this equation, x t is equal to what? X naught sin square t by 2. Okay, that means, to see, this is in x-axis. Okay, this is a center called origin or mean position. With respect to this mean position, the particle executes, okay, motion, that means starts its motion. It is gradually decreases and becomes 0 of its maximum displacement, and then returns journey and possesses maximum velocity while crossing this mean position, and gradually decreases and becomes 0, okay, of its one more, this is plus a, this is minus a. Again it start its returns journey and reaches to the mean position, then we can say the body is executing in, it completes one oscillation. So with respect to position, time, the position keep on change. So how it changes? Velocity gradually decreases and becomes 0 of its mean extreme position. So we can say the body is executing in oscillations. Okay. So with respect to position changes, kinetic energy also changes. So how you should represent this kinetic energy change with respect to position in terms of graph? So you know, in trigonometry you have a formula. What is that? X naught into 1 minus cos t by 2, isn't it? Okay. So here x t is equal to x naught. What is the x naught value as already given? What is that? 1 meter is given. So x naught equal to 1 into 1 by 2 into cos t by 2. So you may write like this, sorry, x naught by 2, x naught into 1 minus cos t by 2. Okay. So you may write x minus 1 by 2 is equal to what? Cos minus cos t by 2. Okay. Therefore x is equal to 0 to 1. That means or x is equal to 0 or x is equal to 1. Okay, so what happened? Particle is oscillating between 0 to 1. Therefore, particle oscillates between 0 to 1. So, now you can draw a graph between position, okay, position and kinetic energy. At 0 it becomes 0 mean position, 0 velocity, that means 0 kinetic energy. It is gradually increases and becomes maximum at of its mean position. Okay, this is what 1 by 2, again cross this mean position, velocity decreases and becomes 0. Okay, it is at 1. So, this is the graph that represent, okay, that represents the kinetic energy versus position. Okay, right. Okay, the sixth question. A string of length L is fixed. This is a string of length L is fixed at one end and carries a mass m, okay, at the other end, okay, second end. The mass makes 3 by pi rotations per second about the vertical axis passing through end of the string as shown like this. It is rotate like this. The tension in the string is, this is asking the tension in the string. First you can draw the free body diagram, then you can easily solve this problem. To see, this is the, okay, point of suspension. Okay, so from this one, at any position the string, okay, make like this. This is the mass m. Okay, you know, tension is away from it. Similarly, tension is away from this point, fixed point. Okay, so this is the vertical axis. It makes an angle, say, called theta. Similarly, okay, the weight, that means gravity, is at vertical downward, which is balances by resolve this tension into two components. This is what is a T cos theta, isn't it? Okay, this is what I say T sin theta. So, from this, okay, in vertical direction, what is that? T cos theta is balances its weight. It is nothing but what I say m into g. This is the equation 1. This T sin theta is provided the necessary centripetal force. Okay, it is revolved in a circular path. So, that what is the T sin theta is equal to what? M r omega square. That means actually mv square by r. Okay, r is v is equal to r omega. So, you can r is cancel. Okay, so it get nothing but what I say m r omega square. This is the equation 2. Here r is equal to, you know, this is the r. R is nothing but this thing. This r is nothing but is a L sin theta, isn't it? So, here r is equal to what? L sin theta. Therefore, what is that? T is equal to, okay, T sin theta, sorry, T sin theta is equal to mass of the string capital M is equal to capital M, r is equal to what? L sin theta into omega square. Okay, and here to see, and omega is angular speed. It make, what is that? 3 by pi revolutions per second into time t. That means total circumference is equal to 2 pi. Therefore, T sin theta, okay, what is the T sin theta is equal to m L, and suppose to see on both sides sin theta is cancelled. Therefore, T is equal to what? M L. Omega square means what? 3 by pi into 2 pi whole square. This pi is cancelled. Okay, 36, that means 36 ml. So, in this question answer is equal to what? 36. Okay, that is it. Okay, the seventh question. Acceleration due to gravity on the surface of earth is g. Okay, suppose this is the earth, on its surface acceleration due to gravity. That means what? Acceleration due to gravity on the surface of earth, suppose to see this is earth of mass m, okay, and the radius is nothing but what I say r. Okay, so on the surface of earth g is equal to what, you know, gm by r square. This is the relation between small g and capital G. Small g is the acceleration due to gravity, capital G is the universal gravitational constant. Here mass is equal to what, mass is equal to volume into density. Okay, right. On the surface of earth is something. If the diameter, suppose it is here r is equal to what, radius is equal to what, diameter by 2, that implies diameter equal to what, that means, so I would like to here r is equal to what, d by 2 is substitute in above. Therefore g is equal to what, gm by d by 2 whole square, that implies what, g is equal to 4 into gm by d square. This is the acceleration due to gravity equation in terms of what is that, in terms of what, mass and density. Okay, to see what is asking, acceleration due to gravity on the surface of earth is g if the diameter of the earth is reduced to 1/3. So from this we can say gravity is inversely proportional to diameter square, isn't it? So on surface of earth, g1 is called g, okay, diameter d1 is called d. Now what happened if the diameter of the earth is reduced to 1/3 of its original volume, that means diameter is decreased to 1/3 of its original value, then g2 is equal to what, this is asking. From this one you can write g is inversely proportional, that implies g d square is equal to what, constant. Therefore g1 d1 square is equal to g2 d2 square. Therefore g1 is equal to what, g, d1 is equal to what, d, gd square is equal to g2, this is the required value, g2 into d2 is equal to what, d square by 9. On both sides d square cancel, that implies g2 is equal to what, g2 is equal to what, from this one, 9 into g. That means what, gravity is increased by 9 times. Gravity is increased by what, 9 times. Okay, right. Right, the 8th question, the increase in pressure required to decrease the volume of a water sample by 0.2% is P into 10 power 5 Newton per meter square. Bulk modulus of water is 2.15 into 10 power 9 Newton per meter square. The value of P is, to see what is asking, the increase in pressure required, that means delta P is equal to what, increase in pressure, that means initial pressure is somewhere, something is there, now it may be increased. So what is the change, that is called increase in pressure required to decrease the volume of a water sample. How much, decrease the volume of a water sample, how much, 0.2%, that means initial value is something, what is that, 100% is there, compared to 100, delta V is equal to what, 0.2%. This is a change in, decrease in volume compared to initial one. Okay, okay, what is the given, bulk modulus is given, what is the bulk modulus is equal to 2.15 into 10 power 9 Newton per meter square. You know, from according to definition of bulk modulus, what is that, delta P by, what is that, delta V by V, isn't it, bulk stress by, okay, change in volume, okay, that means what, minus delta P, which is equal to, that is required, that means delta P by delta V, that is what, decrease, that means what, this is nothing but what is minus, what is that, 0.2 by initial value equal to what, 100, this is cancelled, okay, that implies delta P by, what is that, 0.2 by 100, which is equal to bulk modulus beta is equal to, but beta is given, what is the bulk modulus, 2.15, therefore delta P is equal to beta into 0.2 by 100, beta is equal to what, 2.15 into 10 power 9 into 2 by 1000, that means 0.2 equal to 2 into 10 power minus 1, this 10 power minus 1 go to the denominator, which is equal to what? 10. So, 10 into 100, 1000. So, what is the value? 2 5 is 10, 2 1 is 2 plus 1 3, 2 2 is 4, 43.0 into 10 power 9 into 10 power minus 3, which is equal to 43 into 10 power 6. Okay, 10 power 6. Okay, but in the question, p into 10 power 5, p into what? 10 power 5. So, what is the value of it? Which is equal to what? 4.3 into 10 power 5 Newton per meter square. Okay, so that in place of p, okay, how much? 4.3. So, this is the answer for this question. Okay, thank you. Okay, the ninth question, assertion region type. First assertion, what is that? In an insulated container, let us take an insulated container, that means this container does not allow, okay, anything inside, as well as it does not give anything to the surroundings. Okay, so there is a bad conductor of heat. So, insulated conductor means what? It is a bad conductor of heat. Okay, a gas is adiabatically shrunk. So, the gas inside this insulated container is shrunk suddenly. Okay, half of its initial, that means the temperature of the gas is, that means suppose to see initially, what is that? Initially, what is the temperature of this insulated container containing gas? T1 is equal to T. Okay, T1 is equal to T1. Volume V1 is equal to what? Say V1, suppose, for example. Okay, now what happened? Finally, what happened? Suddenly shrunk. The gas inside this insulated container is suddenly shrunk. Okay, so what happened? Its volume V2 is equal to what? Half of its initial value. That means what? V1 by 2. Then what happened in temperature? You know, in adiabatic process, okay, in adiabatic process, okay, the relation between okay, what is that? Volume and temperature is, what is the relation between volume and temperature in adiabatic process? T V power gamma minus 1 is equal to what? Constant. Therefore, T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. Here what that implies? What happened? Temperature is inversely proportional to, what is that? Volume power gamma minus 1. So, here what happened? Volume is decreases. That means what? Temperature is automatically increases. That means final temperature is what? Increases. But according to given assertion, the temperature of the gas is what? What happened? Decreases. So, it is not correct. So, assertion is completely wrong. Okay, right. Next, reason. Okay, what is the reason? Free expansion of an ideal gas is an irreversible and an adiabatic process. That means to see free expansion of an ideal gas, that means if you imagine this free expansion of ideal gas is very quick, fast, so it is nothing but an adiabatic process. Yes, it is correct. Okay, that is it. So, assertion is wrong, reason is correct, that is it. The 10th question, which of the following figure represent the relation between Celsius scale and Fahrenheit scale of temperature? You know, there are 4 different scales of temperature for measuring physical quantity called temperature. One is called Celsius scale, Fahrenheit scale, Reimer and Kelvin scale of temperature. Okay, here what is asking? Celsius and Fahrenheit scale. You know, relation between Celsius and Fahrenheit is equal to what? C by 100 is equal to what? F minus 32 by 180, isn't it? So, you can write C by 5 is equal to what? F minus 32 by 9. So you may write C is equal to what? 5 by 9 of F minus 32, isn't it? That implies what? C is equal to what? 5F by 9 minus 5 2s are 10, okay, 5 3s are 160 by 9, isn't it? So when you take F is equal to 0, C is equal to minus, if F is equal to 1, C is equal to negative, okay. So whenever you take C is equal to positive, you get foreign, that means if F is equal to positive, what happens? C is equal to what? Obviously negative. So among the given figures, you know, this C and F, this is an origin, but here to see, here Fahrenheit scale is taken as completely negative, while taken as F is equal to negative, C does not give, okay, the value of negative, it is completely positive, isn't it? So it is not correct. When you take the second one, when you take F is equal to positive, obviously you get the value of C is equal to what? Negative, completely. So it may be correct, maybe. While you taking third one, it is completely opposite one, so it is also not correct. This is you take, this is completely in positive, so it is not correct. Why? Because if F is equal to positive, C is equal to what? Completely negative. So from this graph, only second option is correct. So the graph, okay, when you draw between Celsius and Fahrenheit, shown like this, okay, that's it. The 11th question, the magnitude of heat exchanged by a system for the given cyclic process A, B, C, A, okay, as shown in the figure is how much? Okay, to see in cyclic process, what is that? In cyclic process, work done, okay, is equal to, okay, exchange of heat into work, exchange of heat into what? Work. So the magnitude of heat exchanged by a system for the given cyclic process, therefore work done in PV, that means called indicator diagram, okay, diagram, okay, that is nothing but what I say, PV graph. That means when you draw a graph between pressure and volume, which gives rise to the what is that? Work done by the gas, okay. In PV graph, what is that? Work done in PV graph is equal to area under curve, therefore area of half circle, what is that? A, B, C, A is equal to what? 1 by 2 pi r square, 1 by 2 pi r square, okay. Therefore heat exchange is equal to what? 1 by 2 into pi into r. Here r is equal to what? Here to see, this is what? 200, isn't it? When you take volume, okay, from 200 to 400, means the difference equal to what? 200 only, isn't it? Isn't it or not? Yes, that means what? It is nothing but half of, that means what? This diameter by 2 means what? Radius, 1 by 2 into 10 power minus 3, isn't it? Sorry, 10 power 3 cubic centimeter, yes, right, into, when you take this one, this r into this r square, so what is that? It is also equal to 200 into 10 power minus 6, isn't it? 10 power minus 6, this is also by 2, this total equal to 200, half means what? 400 minus 200 equal to 200 by 2, half, isn't it? Okay, right. So that you get 1 by 2 pi 10 power 4 into 10 power 5, 10 square 10 power 3, that means 10 power 5, 10 power minus 4. So equal to get what? 10 pi by 2 equal to what? 5 pi. So this is the, okay, joule answer for this question. 5 pi joule, 5 pi joule, Okay, that's it. Right, the 12th question. The temperature of a body in air falls from 40 degrees Celsius to 24 degrees Celsius. That means, suppose this is a body, its initial temperature T1 is equal to what? 40 degrees Celsius. Okay, which is false, that means decreased from 40 degrees Celsius to what? 24 degrees Celsius. For decreasing this temperature, it may take, what is the time? T is equal to what? In 4 minutes. That means, in this 4 minutes, the temperature of this given body falls from 40 degrees Celsius to 24 degrees Celsius. Okay. Okay. The temperature of the air. In meantime, what is the actually this is totally happened in surrounding. What is the surrounding temperature? Means air temperature equal to what? 60 degrees Celsius. So, the temperature of the body in the next 4 minutes, that is asking. Okay. From Newton's law of cooling, from Newton's law of cooling, what is that? The rate of heat flow, that means the rate of that means the rate of cooling, that means dt by T is equal to K into, okay, T average minus Ts surrounding temperature. Okay, the rate of cooling is directly proportional to excess temperature of the body compared to its surroundings. Okay, here dt means what? T1 minus T2 by time T is equal to what? K into T average, that means T1 plus T2 by 2 minus surrounding temperature. T1 minus T2, that means what? 40 minus 24 by 4 is equal to K into 40 plus 24 by 2 minus surrounding means what? Its surrounding means what? Air temperature 16. What is the value? 40 minus 24 is equal to 16 by 4, that means equal to 4, equal to K into what is the value? 32, isn't it? 64 by 2, 32 minus 16. Okay, that implies K is equal to what is the value? 4 by 16, that means what? 1 by 4. Now, what is the temperature of the body in the next 4 minutes will be? Next 4 minutes means what? After 4 minutes, this is initial temperature. After 4, it is fallen from T2 to T3, isn't it? So, the temperature of the body in next 4 minutes is what is that? T2 is equal to what? 24 degrees Celsius, T3, this is supposed to be calculate, isn't it? So, what happened? T2 minus T3 by time 4 is equal to K. K is equal to how much you get? 1 by 4. 1 by 4 into T2 plus T3 by 2 minus Ts, isn't it? Right. T2 means what? Already 24 is there. 24 minus T3 by 4 equal to 1 by 4. Twenty-four minus T3 by 4 is equal to 1 by 4 into 24 plus T3 by 2 minus Ts. Ts is equal to 16. Surrounding temperature is not changed. Okay, right. So, this 4 is cancelled. Then 24 minus T3 is equal to 24 plus T3 minus 32 by 2. That means what? 48 minus 2 to 3 minus 24 minus T3 plus 32 equal to 0, isn't it? So, solve this one. What is that? 24 plus 32, 6, 56 is equal to 3 T3. That implies T3 is equal to what? 56 by 3, okay, degree Celsius. So, this is the answer for this question. Okay, right.